Okay. Hey everybody, it's Gordon. Welcome to my shop. Not really my shop, it's my dining room. But to start this video off, I wanted to sit down at the table, have a little conversation about what you're about to see and why I made the choices that I did. And I think that would make the video a little bit more informative, if you will. So here's what's going on. Tonight's video is about adhesive, right? The technical word, adhesive glue. And as we're talking about Brazilian rosewood, I do a lot of tote repairs and knobs, and I'm often asked, what glue should I use? What glue should I use? What's the best glue? Well, my answer is one word, depends, right? It depends, because you're either doing restoration type work, restorative work, where we're trying to bring something back to its original beauty and integrity, and there's a little bit of art involved, and it's not a fully functional or something that's going to be durable and out in the field. And the other extreme, of course, is what glue should I put on Brazilian rosewood that's going to make that sucker last for a long time, because I'm going to go work the snot out of this tool. Okay, there's that glue. So I use a number of different things, and I have refined my use of adhesives to a certain field, if you will. And so it's a little bit difficult for me, or at least scientifically, I think someone would say, Gordon's going to be biased because there's things that I like, and there's relationships that I have. And so I'm going to try my best to remove that. And here's how we're going to do it. I took Brazilian rosewood totes and with just the foot, cut them off all the same height, so that I tried to get as close to the same square millimeters or the surface area for all my samples, right? So that's the first thing that someone might say is, well, some of those are different. Yep, they are, but they're pretty darn close. So as a woodworker goes, close enough. Second, I didn't use any chemicals or any prep. I didn't sand them. I didn't wipe them or try and remove any of the surface oils. I just table saw cut both pieces, and we're going to glue them all together. So they were all treated the same. Then what else did I do? I think that was it. I put light clamp pressure on all of them. Normally on epoxies, you wouldn't have to do that unless you're just trying to keep something in place. But again, in the interest of trying to keep them all the same, that's what I wanted to do. Now, I was going to go out to my shop and I was going to load a sandbag or a bucket and just continue to pour weight on this until I got to the point where it just snaps. I want failure of some kind. Glue them, break them, measure it, compare it, and share it. That's really the whole spirit of what I'm doing. If I had to put it into 4 or 5 words, that would be it. So we did the cut, we did the glue. I need to break these, but I know which one is which glue, of course. And yes, I have my favorite. And so how can we remove that? Well, I gotta have somebody else do this. So I sent these, took them to a different location. They went to a lab where they have better equipment, and they're more equipped or better equipped to handle a testing situation like this. I thought it was wonderful. So they have no idea what my background is. They have no idea what my interests are. They really don't care what kind of glue, whose glue, and what's going on here, other than we have 6 samples, add one more, we're gonna call it 7. We're gonna break them all, and I'm gonna share it with you. So that's the nucleus behind what we're doing. And because you probably don't have 7 or 8 rosewood totes that you want to cut up, glue up, and destroy, I thought I'd do that for you. So here you go. You're welcome. Okay. Now, the first round, right, the very first one that went into this lab was on a piece of oak. As you can see, the sled, I'll call it a sled, it's still there. That is red oak. Okay, so it's on a piece of red oak, and that's how it was processed on the table saw. And then, just for good measure, I thought, you know what? We need to pin this thing down, because they're gonna potentially, if it's really good bond, it's not gonna break, it's just gonna shear off. So I went ahead and fastened through the toe, because these are all number 5-ish totes. I fastened through the toe with adhesive underneath, right? And then the very first setup went something like this. Using their equipment, fastened at the toe. The force, let me use this one. The force was applied downward, 4 inches away from the heel. The force was applied downward, and the very first thing it did was just shear the toe off. So we really didn't test anything. And the person knew enough to stop and say, is this really what you wanted? You know, it doesn't look like it accomplished much. And I said, no. So what we did is called a timeout. And then I used someone else's adhesive. I used a 2-part epoxy and bonded every toe right to the oak, then put the fastener back in, okay? And now we tipped them at 45 degrees. Again, still using the measurement, right, at a right angle. So I am 90 degrees off vertical this way, 4 inches pressed down, and hopefully we're gonna snap this thing like a wishbone, okay? That's the idea. In the video, you'll see some of these, the horn was already broken off, and it had geometry something like this. Well, knowing that we were close to the 4 inches and that you may have deflection, we may have some other things there, 45. Now, bring down our force. If we're right at 4 inches and we're on this, we're gonna be doing some weird stuff. So in the sample, and you'll see when there's a video of each of these being broken, by the way, this little bit of a horn, what's left of it, may have been sheared off. But again, it's contact, and the geometry behind it, close enough for what we're doing. We're breaking wood. And my last little disclaimer here is throughout my career, I've been in product development and engineering, and I've worked with some brilliant people. And I do know enough just through osmosis and being around great minds that this is a organic material. It is not aircraft quality aluminum or billet titanium. It's not going to be in its purest form. In other words, there's variation. There's going to be a variable on every one of these samples. I don't know what year this was processed. I don't necessarily know what region or what tree or where it came from. But yes, there will be some differences in these rosewood totes. I did my best to assess the quality of the sample in terms of some of the rosewood parts that I handle are really dry, and you can tell by weight that they're not quite all there, or they are they've been exposed to extreme weather conditions and they have checks and they're already starting to show signs of cracking and whatnot. And so I spent a fair amount of time to make sure that I did the absolute best I could with the samples I have. So that's a long answer to, I did my best, but in the end, it's wood. Okay, before we go, I want to say, stay with me, please, until the end, because I do have something that I think is important that I'd like to share with you, and that'll be at the end of the video. So I don't want to sway you in any way, shape, or form, but here we go. Let's go break some stuff. So what you're looking at is a close-up of the tote itself, glued to its base inside the testing machine. And this is a controlled environment, so it's applying force and measuring it with a load cell and using software to look for any variations. And right away we see the difference in the graph because the heel popped. That's the epoxy breaking loose at the bottom. So we just continue to apply force, and then the toe fractures, and you can hear it cracking in the lab, but also you'll see it on the graph as the thing just starts to fold up on the toe. So the highest amount of weight applied here before the foot on this failed was about 270 pounds. And then here's a quick look at the graph. You can see that first little pop at about 150 pounds is the epoxy letting go. So the second one, now we're on to hide glue, and we're almost expecting this one to do the same thing. We know the epoxy used to adhere or hold this to the base didn't work as well as intended, but we continue to try and fold this thing over. think with this one too, again, we apply a lot of force, and then eventually the toe breaks. And this one was a little more distinct, I think, in its fracture. And you see that in the graft as it falls off as well. And this one hit about 156 pounds before the graft started to slide off, which really means it's not going to get any higher, and we're definitely not going to break it at the joint. But there's that fracture. And you see the graft fall off. So the third one we did was the CA glue. And again, as I said in the intro, this one really surprised me. And the tote itself wasn't quite long enough for the 4 inches, so we glued a wedge on there so that we could apply that same setup to every sample. And then this one, the base let go, that cracked. And we see some fractures, but this one surprisingly will break the rosewood before the glue joint. And you'll see that here at the end. And I'll turn the sound back on here so you can hear this one pop. This is finally kind of what we were looking for on all of them. And then you see the graph here where the heel let go. We continued to apply force until it finally fractured. Next up is our Tight Bond 2. This one went pretty quick. A lot of force, real fast. And here we have the polyurethane. So this is Gorilla Glue, which if you've ever used it, you know that you have to use moisture on one side and adhesive on the other. And it's moisture activated, and it will foam and expand. So this was assembled and then held in place with a clamp. But as I'm talking, you'll see this one separate at the glue joint. So this one did fail at the glue joint, and it's I believe the only one of our samples that really produced any surprises. So if you're looking right at the heel where the foamy joint would be, we'll kind of speed this up and then it'll let go. Max force on this one was 100 pounds. And you'll see the graph when we got up to about 100 pounds, and then it just leveled off.
There we go. All right, 0.
Then we have the G2 epoxy.
Started it.
And you guys know I use this product a lot, so I was really trying to hold my breath and root for it, without swaying the results. But the people in the lab had no idea what was going on with these different samples. Even though I did write on the base, you can see where I identified them. Didn't mean anything to them. But in this case, the heel lets go, just like all the others. We continued to apply force. And I just wanted him to fold it over and snap it. And we just kept going until the toe breaks. I think we eventually got to 213 pounds on this one. Super impressed with the strength of this material, the rosewood that is. And then once the toe broke, you can
That's
see
into
we just
that,
bent
yeah.
it right over. So on to our final sample, and this is the one where I just took G2 epoxy, slapped it on a tote that was right in a bin, didn't clean anything. I really didn't expect this to hold very well. It's not a tight joint, as you can see, because it wasn't really prepped. But I just wanted to throw this in there as an example of what might happen if you don't spend the time preparing your surfaces. But much to my surprise, this held really, really well. If you're looking at the adhesive down where the rosewood meets that red oak, you'll see it. It's really slow, but it's pulling apart and lifting that heel up just like it did on every other sample. And these are all in slow-mo, so I apologize for the time that takes to get through this, but I was really expecting some dramatic results, so we wanted to go in slow-mo to capture them all. And then I think right about here is when it popped and it finally lifted up off the base. And you'll see that in the graph. That would be recorded in the software. And then we just kept pressing. Keep pushing forward and try and break this. That was the goal. You can see some of the epoxy had leaked down that center hole. That's what looks like a tail there. We got to about 200 pounds on this one.
Did that break?
Okay, and we're back. Well, it's time for a quick commentary. I don't know if that was like watching paint dry or if it was like watching totes crack, but what did we learn from that? We learned a couple things that are, I think, positive. We learned a couple things not to do as a setup guy. And so let's get right to it. The T88 product, which is a System 3 two-part epoxy, that's this guy, right? I have not talked about this much. I have not used the product much, but I have talked to the company. I've talked to System 3, and it was one of their technical people that pointed me in this direction because I asked the question as I'm working with Brazilian Rosewood, and I know that they recommend the G2. I said, is there any other products that I'm missing out on or that I should be aware of that would do perform in a similar fashion and would give me the bond that I need, maybe longer or shorter working time, but the same ability to tint and do whatever. And T88 was brought up. So there it is. And that's the T88. That's this guy, okay? So what happened? In the video, you saw, and you will see in the graph, the pressure being applied, right? So it's 4 inches off this back. You can see the dent that it left in the toe. But as this force is being applied, the technician says failure, and you see it in the graph. That's this heel breaking loose. Okay, so that was the first indication of failure. And what my instruction was just keep going, break it. I want it to break. I don't want to know what just failed and that we have some movement. I want to see this thing break. So what you saw was 270 pounds of force applied to this sample. And guess what? There's fractures. There's some almost like shear fractures in the toe of this, but the bond itself didn't break and the rosewood didn't break. So imagine, if you will, right, this little guy on your plane and you're pushing 270 pounds of force behind it. I love that bond. I have no issues with this. What I do have issues with is, I'm not going to bash on anybody because I did this, the epoxy that I used to hold these down was not on the table at the moment. It's a different brand and it cured, but what happened was it separated in some areas, and I pulled the rosewood and the oak apart. So from an engineer point of view, I wish I would have held on to this in a different way. However, I'll qualify it by saying this. I didn't want to put the rods in these and squeeze them because now it's a mechanical assembly shrouded by wood, and we've got so many different forces in there. I just wanted wood. I wanted rosewood and adhesive, and I wanted it to break. So I'm happy. I'm disappointed that the heel separated, but I believe that we still have a measurable feel for what this is capable of. And again, T88 product, System 3 epoxy, 270 pounds applied to this, did not break at the joint, and the wood didn't break. I love it. I will use that product, absolutely. Okay, what happened next? Hide glue. I have no experience with hide glue other than I've disassembled furniture and I've read about hide glue. I've never made my own, but I bought this product, and this is a Titebond product. And again, all of these things that I'm using are new. This guy held on. What did we get? 156 pounds. And you'll see in the graph that the heel broke. Again, the epoxy that was supporting this let go. There was some movement, and then we got to the point where there was a bigger fracture. So this guy broke, right? That's a pretty clean break. I can pull this apart if I wanted to. But that hide glue went 156 pounds. And again, it didn't fail. So we know we're way north of that. And that's what's going on with the hide glue. So I love that product. I'll probably play around with that a little bit more. This, again, I don't have any experience with it, but no complaints there. I was impressed. Next was the CA glue. Okay. Here's what's going on with CA glue. This was a nice sample of rosewood, and what you saw was, in the picture, my explanation is this. This tote fell a little bit short and had a funny angle on it, so we glued with an epoxy an extension on here just to give it the same leverage that everything else got. So at 4 inches, the forces were applied. This one popped at 297 pounds, okay? Almost 300 pounds of force applied on this tote, and the wood broke, okay? So what does that tell me? This is telling me that Starbond thick brown CA glue with no accelerator on a clean surface on a tote did amazingly well. That's really, there's nothing more to say. I was impressed with this. This is not a product that I use on my mid-body brakes, but there it is. For those of you that have done CA glue, or you prefer CA for all of your tote repairs, I got nothing to say. It's sticky stuff, and it did well. I didn't think, I will admit this, why am I pausing? I didn't think it would hold like that. I thought that's where we were going to see the break, but I was wrong. Starbond, you got that going on. Okay, Titebond 2. I went with Titebond 2. I think I said it in my earlier video. I use Titebond products for all my woodworking projects except my Brazilian rosewood. So it's just not something that I use. It's not that I don't like the product or I don't support the product. I think it's amazing. I like to tint my adhesives and try and color match and do a lot of stuff. And using the regular glue and the Titebond products isn't something that I would tint or mess around with. But here we are. This happened to break at 104 pounds of pressure. And we know from the video, you saw it in the close-up, the joint didn't break. Unfortunately, the tote broke. And this too, it's a nice piece of rosewood. It's dense. It's got a really good solid feel to it. I don't know why it broke, at 104, but it did. This was my earlier statement about organic materials, and that, this is not billet aluminum. It's not titanium. It's not a pure alloy that we can, break down and metallurgically review. It is organic. It's a tree, and I don't know its history. So unfortunately, it broke at the wood, not at the joint. So what we do know is that it failed at 104 pounds, And we know that tight bond glue is going to give me more than that, right? Because it would have let go otherwise. So is it worth reevaluating or putting another sample through the lab again? We might. I don't know. We'll see if where this goes. But there it is. Enough said. Polyurethane, huge disappointment. This is something that I did not expect because, as I said, I have used this in the past. I've filled some large voids and gone back, but clearly in the video, when the forces were applied, this one failed. You see it in the graph, and the failure in the video, if you're looking right here, you can tell is exactly on the glue line. This did not separate the wood at all. This sample was handled the same as all the others. It was light pressure. And of course, with the polyurethane, this foams and it expands. This had to be clamped. If it wasn't clamped, it would have, pushed itself apart and would have been a hot mess. So this was treated just like every other one. What I did learn from this whole exercise is that I would never use a polyurethane glue on a Brazilian rosewood tote, okay? Other applications, sure, that's not why we're here. We're talking about rosewood. So I would steer clear of the Gorilla Glue for Brazilian rosewood. And again, just to take the variable out, this is a brand new bottle. I bought it just for this exercise. It's not something that's been sitting around. Okay, what's next? G2. G2, one of my favorites. I use it a lot. And I love that I can mix smaller samples. I can mix batches to suit. I can tin it. I can play art, nouveau with it. It's a beautiful product. And again, I wish my Bond, my off-brand epoxy, would have held because we would have been north of 200-300 pounds before this broke. And I'm confident enough to say that I'm sure, like the other samples that broke on the wood, this joint is solid and it's going to stay. But let the science speak for itself. Where did we go? We went to 213 pounds and the toe broke. So we have a fracture up in the toe and the machine was just going to keep pushing down. So they called it. But there it is. There's the G2 sample, super solid. I love that product. And then last but not least, I was wrong again, right? And this is my dirty, unprepared rosewood tote experiment. So I took this guy, again, this is a pretty good tote, right? There was a lot going on there, and you can tell by the way it's cut and the density and the ring of this product. It's a solid piece of material. It was broken. I put G2 on it with no surface prep at all. Threw this back together, and I thought mathematically it would at least fall 80%. The impurities or however the lack of preparation, lack of penetration would show up somehow and back or substantiate my statements about, you got to treat your surfaces right. Well, guess what happened? Where did we come in? The G2 no prep was 207 pounds, right? And this is a longer sample, but you can see the dent right back here. It's at 4 inches. So this came down at 207, so just a couple pounds away from the other failures, but still north of 200 pounds with no surface prep at all. So kudos to System 3 and the way that one performed. So there you have it. What could I have done differently? This is a fixture that I use in my shop as I'm working on totes and repairs. It does have the rod in it, and yes, that's part of an old corrugated plane, a number 5, and it's been mounted so I can put this on my vise and move it around, do whatever I want. So as I got to thinking about this and the way it went, maybe, just maybe, we will mount something just one time with our favorite glue to see if we can find a real number. What would it take if I have the bolt in the toe and the rod all the way through it, materials under compression, and this is being held, and I put force on this? What kind of force do you think it would take to actually crack this piece of rosewood? And I can, just by what we have in front of us, it's going to be in the 350, 400, maybe even 500 pound range. which I think is incredible given this small piece of wood that's roughly 3/4 of an inch in diameter. It's probably 100 years old. And if it had its mechanical reinforcements in it, you know, the ability for this to withstand forces and withstand abuse is beyond what I ever thought. I really thought our numbers would be in the 80 pound, 90 pounds, maybe 100 pounds. You'd hang something on here and it would just snap. But I'm so impressed with the way that these performed that it brings kind of a new appreciation for those handles that are intact. If the epoxy failed right at the joint, I always go back to my cup, because what is right here is what's in the middle of that toe. So if you just put your fingers under it and bend it, you can tell if it's cured. If it's sticky, tacky, flexible, right? If there's something going on. Same with this one. You know, it's pretty stout. That's good stuff. That's T88 right there. So, and then why did I do this? This is usually what's on my bench, right? If I can give you a better look at that. This is why I prefer a 2-part epoxy. Clearly, the performance of some of these adhesives is much better than what I ever imagined. And it kind of reaffirms my beliefs in some of the products that are on this table. But if you ask me again today, what would I use for a tote repair? I'm going to go for those 2-part epoxies. I'm going to go for the System 3 products, because when I mix this, I have the ability to work on what is like a palette. So for my clear, I can work in a clear puddle. I put browns and other colors and rust and kind of mix, and I can match the color of the material and work right within my little tray. And then I apply my adhesives. Is it really that big of a deal? To me it is, because it's one less thing. If I didn't care, I just mixed up something that was clear, it's going to shine or it's going to stand out, then then why bother? I guess, I don't know. That's dumb. No, I just if I'm going to mix up any other adhesive and apply it, and I don't really care about the color, it's just one more little detail that I have to deal with when I'm trying to make that repair go away. Okay, so you've seen the video, you've seen the lab test, you've seen the numbers, right? And you knew what happened. And as I said, my one regret with this is that no regrets, right? My one regret was that I didn't use the right epoxy when I bonded my samples to the little fixture. So I don't know what I was thinking, but I do. I was trying to get rid of something that I had for a while, and I thought, oh, here's a great application for it. I put it on there. Bad move, Gordo. Why is that a bad move? Because in the light of that, I'll make this statement. The folks at System 3 have been amazing. They've been very technical, very supportive, very helpful, very responsive. They even went above and beyond with one of my questions to mix their own samples in their lab and then share results back with me, which I thought was just amazing. I'm totally sold on System 3 products. And I wanted to say at the end of the video that they did send me products and they helped make this possible. I was able to put the T88 product in. They sent this awesome little mix gun too for the T88, which is in the cartridges with the mix nozzle. Love this, thank you very much. And I'm forever sold on the System 3 products, and I hope that you are too. Not just because they're sending me stuff, but because of the ability to have a long open time, have a superior bond, have the ability to mix colors if I want to, or if I don't. And again, the technical experts demonstrated to me that this is a company that you want to do business with. Totally confident in it. I'm totally confident in the product, and I really know that they're going to be there for me if I need them. Okay, so that's the end of that, and I hope that you'll stick with me. I hope, no pun intended, I hope that you will, if you have questions, put them down below. Find me. I'm on Instagram and Facebook as well, and I'm always out there for you, trying to do these things to help you do better at what you do. So to see you again soon. All right, I can't see you, but you know what I mean.